Questions 21 through 25 on the 2019 Grade 10 AMC 10B. Deborah flips a fair coin repeatedly, keeping track of how many heads and how many tails she has seen in total, until she gets either 2 heads in a row or 2 tails in a row, at which point she stops flipping. What is the probability that she gets 2 heads in a row, but she sees a second tail before she sees a second head? Well, we have to figure out what kind of scenarios this would happen in. The first one is if it's tails, heads, heads, heads. So let's talk about this. 2 heads in a row, so that's when she stops flipping. She gets 2 heads. Okay, that satisfies that criteria. But the second criteria is that she sees a second tail before she sees a second head. Here's the second tail, here's the second head. She indeed saw the second tail before she saw the second head. So this is the first scenario. And the probability of this, probability of getting a tail is a half, probability of getting a head is a half, a half, a half, a half. So basically it's 1 over 2 to the power of 5. That probability. Okay, the next scenario is very similar. TH, T, H, T, H, H. Satisfies that criteria. We didn't get 2 T's in a row, we got 2 H's in a row, but we have seen the second tail before we saw the second head. So that satisfies that criteria. Here the probability is 1 over 2 to the power of 7 this time, because there's 7 halves. And similarly, I'll do one more. It would be TH, 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 TH. Again, that criteria is satisfied, and the second head is before the second tail. Here, the probability is 1 over 2 to the 9th. And it just keeps on going like that. So the total probability, you would add them all, 1 over 2 to the power of 5, plus 1 over 2 to the power of 7, plus 1 over 2 to the power of 9, ... It just keeps on going, right? And this is what is known as an infinite series. Infinite geometric series. And in an infinite geometric series, the sum is a over 1 minus r, where a is the first term and r is the common ratio. The first term is 1 over 2 to the 5th, and the ratio looks like it can be calculated by putting the second term over the first term. That's the easiest way of calculating it. And when you do that, you get 1 over 2 squared. So that seems to be the common ratio, which is 1 over 4 basically. So that's 1 over 2 to the 5th over 3/4, invert and multiply, and you get 4 over 3. So this looks like 4 over 32 times 3. So that's going to be 1 over 8 times 3, and that is 1 over 24. And therefore, number 21, the answer is B. Rashawn, Sylvia, and Ted play the following game. Each starts with $1. A bell rings every 15 seconds, at which time each of the player who currently has money simultaneously chooses one of the other 2 players independently and at random and gives $1 to that player. What is the probability that after the bell has rung 219 times, each player will have $1? Well, we have the following scenarios. I'm going to need some space for this. You have Rashawn, you have Sylvia, and Ted. Now, Rashawn, he can give to either Sylvia or Ted. And then Sylvia can give to either Rashawn or Ted. And then Ted can give to either Rashawn or Sylvia. Like that. So those are the only possible ways of doing this. So let's label these now. The Rashawn to Sylvia I'll call 1, this I'll call 2, this I'll call 3, this I'll call 4, this I'll call 5, this I'll call 6. So our possible ways of doing this are 1, 3, 5, 1, 3, 6, 1, 4, 5, 1, 4, 6, or you can have 2, 3, 5, 2, 3, 6, 2, 4, 5, or 2, 4, 6, like that. So for each of these, if you go through it, they all start with $1, right? The dollar is the initial amount. So if you start with $1, $1, and $1, and then you go through 1, 3, 5, what happens? I'm just going to do it for a couple. I don't want to go through every single one. I don't want to talk you through every single one because that's going to be painful to listen. But let's just do the first one. 1 is this guy right here. R goes to S. And then 3 is S goes to R. So R goes to S, S goes to R. So those cancel each other. So that's just going to be 1, 1 like that. He gave that dollar, but then he got the dollar back. And then the last one is this one. T goes to R. So if T goes to R, then that means that this $1 goes to R. So he's going to have 0 and he's going to have 2. So 2, 1, 0 is what happens there. All right, so I'll just do one more, talk you through one more. 1, 3, 6. So 1, 3, and 6. So in the same way, the R goes to S, but then S goes back to R. So those cancel, but then T goes to S this time. So because T goes to S, it'll be 1, 2, 0. And if you go through all these, the result is 1, 1, 1 for that, 0, 2, 1, 2, 0, 1, 1, 1, 1, 1, 0, 2, and 0, 1, 2. So these 8 are the 8 and only possible end results. And if you're practicing, I challenge you to try to find any others. You won't be able to. You'll notice that no matter what scenario you do of these 8 scenarios, you'll end up with one of these 8 possible end results. So we, in our question, want to end up with 1, 1, 1. Well, that's 1, 1, 1, and that's 1, 1, 1. So of the 8 possible ways of ending, 2 end up the way we want. So 2 out of 8 is the probability, which of course in lowest terms is a quarter. And that's it. So number 22, the answer is B. Points A, 6, 13, and B, 12, 11 lie on a circle W in the plane. Suppose that the tangent lines to W at A and B intersect at a point on the x-axis. What is the area of W? This diagram helps to illustrate the question. So let's talk about this. So we have points A and B right here, and they are on a circle. And then the lines that are through that are tangent to the circle, so that basically means that this is a right angle, and this is a right angle. And these are the radii from the center, which is denoted as O. So I'll just write radius right there, R and R. And those tangent points intersect all the way down here at this point T. Now we have to first show how to get that point T. It's labeled, but we have to show how to actually arrive at that. The first thing, of course, is that if you draw a line straight from A to B and then draw a line from that point to there, since we have an understanding that that is equal to that, because any line that's drawn from the same point to a tangent point will be equal. So that is equal to that. This is essentially an isosceles triangle. So if you draw a line down the middle that's perpendicular, which this is basically, it will cut that line in half. So M will be the midpoint of this line. So we can figure out the coordinates of M pretty easily. It's the midpoint of A and B. So it'll be 12 plus 6 over 2, and then 11 plus 13 over 2. So that is going to give a coordinate of 9, 12 for m. Now what I want to do is I want to figure out the slope. I want to figure out the slope of that line, and then that will help me figure out the slope of a line that's perpendicular to it. So the slope of AB we can get by rise over run, of course. So the rise would be 13 minus 11, and the run would be 6 minus 12. So that looks like minus 2 over, or 2 over minus 6, so negative 1/3. So the slope of a perpendicular line, which is basically this guy right here, it would be the negative reciprocal. So the negative reciprocal of negative 1/3 is just 3. So that means the equation of that perpendicular line, which is right here, is going to be y is equal to 3x plus b. And since m is on that line, I can sub that in. So 12 for y and 9 for x. And when I do, I get b is equal to negative 15. So that equation is y is equal to 3x minus 15. Now, that line goes all the way down to the x-axis, so I can figure out that point by substituting y equals 0. When y is 0, 3x minus 15 is 0, and therefore x is equal to 5. So that's how we got that point, 5, 0. Okay, so now we move to the next part of the question. The next part is going to concentrate on this line right here, a to t. And a to t, that slope, again, we can calculate that, rise over run. That's going to be 13 minus 0 over 6 minus 5, which is 13. So the slope of a perpendicular line, which is this one right here, is going to be the negative reciprocal. So the slope of AO will be negative 1 over 13. So the equation of AO would be y is equal to negative 1 over 13x plus some b. And then since this is on that line AO, I can sub in 6, 13. So 13 would be equal to minus 1 over 13 times 6 plus b. And when you solve for b, you get a 175 over 13. So that equation is y is equal to negative 1 over 13 plus 175 over 13. And that is the equation of AO right here. Now, we have AO and we have this line, OT, I guess. And the equations are as follows. This was the equation of AO, line AO. And this one right here was the equation of line OT. And we want the intersection point, because the intersection point is going to be O. So the intersection, you set them equal to each other. Minus 1 over 13 plus 175 over 13. That should be x there, is equal to 3x minus 15. And when you do this math, let's see here, multiply through by 13, and we get minus x plus 175 is equal to 39x minus 195, and therefore 40x is equal to 370. So x is equal to 37 over 4. Substitute that back into this, and when you do, you get a y value of 51 over 4. So the coordinates of O are 37 over 4, 51 over 4. Okay, now we can find out R. R, we can use either one. Since we have the coordinates for that, and A, we can use the distance formula to figure out R. So the distance formula, R will be equal to 37 over 4 minus 6. Remember, the other point is 6, 13. So you're just using the distance formula on those 2 points. Squared plus 51 over 4 minus 13 squared, and all under the square root sign. And I'll let you crunch those numbers out, and when you do, you get 1/4 times square root of 170. And then finally, we have to figure out the area of the circle, and that's just pi r squared. So pi times the square root of 170 over 4 all squared, and that is of course going to be 170 over 16 pi. In lowest terms, 85 over 8 pi. 85 over 8 pi is C for number 23. Define a sequence recursively by xo is equal to 5 and xn is equal to xn squared plus 5xn plus 4 over xn plus 6 for all non-negative integers n. Let m be the least positive integer such that xm is less than or equal to 4 plus 1 over 2 to the power of 20. In which of the following intervals does m lie? Alright, so the first thing I'd like to show is that xn plus 1 is obviously this guy right here. And if you subtract from it xn, you would get the following. It would be xn squared, just that whole thing up there, plus 4 all over xn plus 6, and then you're subtracting this xn. And when you crunch out these numbers, it reduces to 4 minus xn over xn plus 6 when you get a common denominator and all that stuff. And that is xn plus 1 minus xn. Now at this point, we have to do a little bit of recursive formula number crunching. So they told me that x0 is 5. When I put that back into the recursive formula and I get x1, you get approximately 4.9. If you do it again, you get approximately 4.82, and then x3, 4.74, and so on. x4 is 4.67. So as you can see, it's going down, obviously. x5 is 4.60, x6, 4.54. So in this question, we're going to approximate. And we're going to approximate by saying xn obviously looks like 4 plus what looks like a very approximate 9 over 10 to the power of n. And eventually, it's going to get closer and closer to 4. So what I'm going to do is to approximate, I will let xn equal 4, but only in the denominator. And therefore, this is going to give me xn plus 1 minus xn is equal to 4 minus xn. And then I'm using 4 for the xn plus 6. So xn plus 1 would be equal to, if you bring it over, it would be 4 over 10 minus xn over 10 plus xn. And that is going to be 2 over 5 plus 9 over 10 xn. And here is a slightly easier recursive formula. So we have been told in the beginning that x0 is 5, right? So we can use this to figure out x1. It would be 2 over 5 plus 9 over 10 x0, which is 5. So that looks like 2 over 5 plus 44 5 over 10. So that's going to be multiply top and bottom by 2. 4 plus 45 is 49 over 10. And that is, of course, 4.9. So we go through this again, this recursive formula, x2. x2 is going to be 2 over 5 plus 9 over 10 x1. x1 is 49 over 10. So that means x2 is going to be equal to, if you multiply top and bottom by 2, 2 times 2 is 4, 9 times 49 is 441, so we have 445 over 10. Sorry, the common denominator had to be multiplied by 20 there. So that's actually 40 plus 441. So that's 481 over 100. And that's equal to 4.81. So I had 4.82. Okay, approximately. We can put 4.81. I don't mind. Let's put 4.81 like that. And let's just do one more. So x3 would be, again, using this recursive formula, 2 over 5 plus 9 over 10 times 481 over 100 this time. So 1,000 is the common denominator. So 200. So that's going to be 9 times 481 plus 400. And that's over 1,000. So that's going to be 4.72. And so on. So if you use that recursive formula and you get the numbers, the good news is that because the denominators are 1,000, 100, it makes it easier to figure out the number. It becomes 4.6561, and then it becomes 4.59, and then 4.53, and so on. So that's how we get this approximation. Hopefully that was a little bit more clearer. So we basically boil this whole thing down to xn is equal to 4 plus 9 over 10n. And this is, of course, still an approximation, but it helps us. Now, we want this guy to resemble what they told me in the question, which is that xm is less than 4 plus 1 over 2 to the power of 20. Now, these look awfully similar. That means if this is indeed true, then this has to equal this. So that means that 9 over 10 to the power of n has to equal 1 over 2 to the power of 20. Okay, I think that is solvable. We can use logs. So the log of 9 over 10 to the power of n would be the log of 1 over 2 to the power of 20. So bring the n out front and then use log rules to get log of 9 minus the log of 10, like that. And on the other side, it would be the log of 1 minus the log of 2 to the power of 20. So that means n would be equal to, log of 1 is 0, and then minus 20 log 2 over the log of 9 minus the log of 10. And this is, even without a calculator, you can approximate minus 20. Log of 2 is about 0.3. And then the log of 9 is about 0.95. And the log of 10 is just 1. And this, when you crunch out these numbers, gives about 120. So this was all an approximation. And they want you to figure out n is in what range. So that's a good thing because they give you a wide range. And as long as you're in that wide range, you're fine. So let's see where 120 lies. Well, it safely lies here. I would have had to have been extremely off on my approximations to get it outside of that range. So number 24, confidently we can say the answer is C. How many sequences of zeros and ones of length 19 are there that begin with a 0, end with a 0, contain no 2 consecutive zeros, and contain no 3 consecutive ones? All right, well, this question, we've got a few scenarios here. And we're going to need to make a table and talk about them. Okay, so there is 19 slots, and we have to put either a 0 or a 1 in each of those slots. So we have to figure out how many zeros and how many ones. Well, they gave us a couple rules that you cannot put 0, 0, and you could not put 1, 1, 1, like that. So if I start off with a 0, my next number cannot be a 1. It cannot be a 0. It can be a 1. Okay, so 0, 1 is allowed. So I think the 0, 1, 0, 1 will be fine, like that. And here you go. Here's a string of 19 of these numbers. And this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, and obviously 9 ones. And there's only one way of making such a sequence. So that one is pretty straightforward. We're done with that. Now we want to see, okay, for the number of zeros, how many more can I put? Or how many less can I put? Can I put any more? Well, if I put a 0 anywhere where there's a 1, it fails the test because I can't have a 0, 0. So that means I can't put any more than 10 zeros. But I can put less than 10, I can put 9. If I have 9 zeros, then I have 10 ones because the total is 19. Okay, so now let's talk about this. I have 9 zeros, so 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, but how do I place those ones? I've got 8 gaps. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 of these gaps between the zeros. And I've got to place those 10 ones in those 8 gaps. But how do I do that? Well, there's 8 and there's 10 ones, so I'm going to have to double up on 2 of them. So for example, if I put 1, 1 here, then I can put individual ones in all the others, and that'll add up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But that's just one way of doing it. How many are the total number of sequences? Well, from the 8 gaps, choose 2 of those gaps to place those 2 1 ones. Got it? So in this case, for example, I chose those 2 gaps. But I can choose any of those. And then that's it. The other 6 gaps that will be remaining, you choose all 6 of those to place the 6 individual ones. And that takes care of the 9, 10 scenario. The next one is if you have 8 zeros, and then of course you would need to have 11 ones. So then we have 0, 0, 0, 0, 0, 0, 0, 0, 8 of those. And we got 1, 2, 3, 4, 5, 6, 7 gaps. So 7 gaps this time between the zeros. And we've got 11 ones. So how do I place 11 ones? Well, let's see here. I could put 1, 1, 1. But that's not allowed. I can't put 3 ones in a row. So I have to put individuals or just 2s, like 1, 1. 1, 1, 1, 1, 1, 1, 1, 1, 1. Does that add up to 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So from the 7 gaps, I've got to choose 4 of those to place those 4 1 1s, these guys. And then from the remaining 3 gaps, I choose 3 to place the individual ones. Okay, that takes care of that. And then we have the last one, which is 7 and 12. Here I've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 gaps. And the 6 gaps have to hold 12 ones, and there's only one way of doing that, by putting 1 ones in each of those gaps. Because if you put an individual, then the 1 will have 3, and that's not allowed. Okay, I think we're done. There's only one way of doing that. So now all I have to do is figure out these numbers. Well, this was just 1, and this was just 1. So 8 choose 2, I got to figure that out. And I believe 8 choose 2 is what, 28? 6 choose 6 is just 1. So 28 times 1, which is just 28. 7 choose 4, that is 35. And then 3 choose 3 is just 1. So it doesn't really matter. 35 times 1. So now the total number is this 1 here, plus that 28, plus that 35, and plus that 1. And that grand total is 65. And therefore, number 25, the answer is C.